All right, hello everybody. So we've got a question here about vectors, and it's slightly a weird question. So we're told that vector A is P to R, and vector B is R to P, and we're told that those components are arithmetic sequences. So if you add the same difference, you'll get from P to 2 to R, and then on B, it's in the reverse order. So R minus D is 2, and 2 minus D is P. So they're arithmetic components. And so P plus the common difference is 2, 2 plus the common difference is R. In other words, if I solve for D, then I get D equals 2 minus P, D equals R minus 2. In other words, one version of D has to equal the other version of D. R minus 2 equals 2 minus P. So R plus P has to equal 2 plus 2. Oops, I wrote that backwards. R plus P, if I add P to both sides, and I add 2 to both sides, I get R plus P equals 4. So I don't know how I'm going to use that, but I will. Then it tells us that find an expression for cosine theta. And I'm going to find an expression for cosine theta, and it wants me to then also prove that cosine theta is equal to 6 minus d squared over 6 plus d squared. Okay, so here's what I know. I know that cosine of theta for any vectors, any two vectors, is equal to a dot b divided by magnitude A, magnitude B. So let's compute A dot B. A dot B is just P times R plus 2 times 2 plus R times P. So I'm just doing X times X, Y times Y, Z times Z. And on the bottom, magnitude A is the square root of P squared plus 2 squared plus R squared. And magnitude B is the same darn thing, just written in the reverse order. So if we simplify that, on the top we have 2PR, or RP, 2PR plus 4. And on the bottom, we have square root times square root, so they cancel out. P squared plus 4 plus R squared. Somehow, we're supposed to get this in terms of D. So maybe my idea of solving for R and P was not the right idea because I want to get the letter D instead. So I'm going to kind of reverse, this happens sometimes, just sort of reverse what I'm doing here and get that P equals 2 minus D, and then we also have R equals 2 plus D. And then we're going to sub those in and just see where we end up. So 2 times P, 2 minus D, times R, 2 plus D, plus 4 on top. Somehow I hope that becomes 6 minus D squared. And then on the bottom, I have P squared. So 2 minus D squared plus 4. Oops, I threw an extra parenthesis there. Plus R squared, 2 plus D squared. Okay. So on the top, if I do 2 and 2 minus D times 2 plus D, that's going to simplify to be 2 times 4 minus D squared, because there's a plus 2D and a minus 2D that cancel out. Plus 4. And then on the bottom, I have 2 minus D squared becomes 4 minus 4D plus D squared. There's a plus 4 in the middle. And then there's a 2 plus D squared. So 2 squared, 2 times D, and then another D squared. And believe it or not, this is going to work out just fine. So what I'm going to do is I'll just try to squeeze it in on the bottom of the screen. On the top, I have 8 minus 2D squared plus 4. And on the bottom, 4 plus 4 plus 4 is 12. The negative 4d and the positive 4d cancel, and I have plus 2d squared. On the top, I have 12, so that's 2 times 6, and I have minus d squared. And on the bottom, I have 2 times 6 plus d squared, which simplifies to what we were asked to do. Part B says find what d equals, find the common difference, given that there's an angle of 60 degrees. The cosine of 60 degrees is 1/2. So if I set this equal to, for part B, if I set this equal to 1/2, then I'll be able to solve it. Let me create a little bit of space up here, and where this shouldn't take very much to solve. Okay, so if I multiply, I'm going to cross multiply. So 2 times that, 1 times that. So I have 2 times 6 minus d squared equals 1 times 6 plus d squared. So I have 12 minus 2d squared equals 6 plus d squared. 8, not 18, sorry. Subtract 6, so I get 6. Add 2d squared, so I get 3d squared. Divide to give me 2 equals d squared, which implies that d equals plus or minus square root of 2. There you go. Let me know if you have any questions.